Hi, I'm Erin Browning, and one thing I want to say is after this presentation, I'm going to post my slides up on this URL. So you're welcome to, later this evening, check that out. So I'm Erin Browning. I'm a senior security engineer, aka I'm a hacker. People pay me money to go break into their websites. Like, there's not many career tracks where you get to do something that's otherwise illegal for like real money. Oops. If you have questions about this presentation, you can contact me at my email address, which is erin@frowning.wtf, or you can hit me up on Twitter at @evefrowning. So you probably noticed on the program that my employer is listed as Latacora. I left Latacora about a month ago. A great group of people. They do consulting for small security small startups who want to hire their first security person. So if you're in that position, definitely look them up. But as of last week, I'm now at Slack. This is my second week of work. Thank you. They very graciously allowed me to still come and speak. As long as I mentioned this. Slack is hiring. You can check on slack.com/jobs, and one role that may be of particular interest to LISA attendees is we are looking for developers who want to build security frameworks, libraries, and other tooling. So if you're interested in that, you can also hit me up. So one thing you're going to see throughout this presentation is a bunch of code-blocked URLs that are all frowning.wtf. They're all fake. Please don't be the goose and do crimes and attack my website. The website is like a static site hosted on AWS S3, so you're not really going to get anything out of it. But don't do the crimes. Despite what my shirt, despite what my shirt says, you can enjoy crimes without doing them. You can be the goose. So the crux of the problem I'm going to be discussing, I'm an attacker. I want to take over accounts on your website. What that means is I either want to acquire money out of your website, or I'm doing it for the lulz. One of the easiest ways I can get money out of your website is through account takeover. And the more highly privileged the account, if I can get your internal admin users, the better. So your site's probably going to look something like this. You're going to have some kind of API. It's probably at www.whatever.com/API. You probably have a front-end client running on www. You probably have some monolith code serving HTML and JavaScript, as well as your front-end JavaScript client, because you're moving towards the future. You also probably have some mobile clients that are talking to API. And then for your website, your session is probably going to look like one or more of these. You're probably going to have some JSON web tokens, depending how you do authentication, especially if you do SSO. You're probably going to have some randomized session tokens. Most monoliths have that. Those can be stored in cookies. You might even have some API tokens that never get rotated. Rotate your API tokens once in a while. So as you break your website out from a monolith to microservices and APIs, how do you store sessions or tokens between an API or other microservices and your browser-based front-end client? Like, where should you put those? So Auth0 is an SSO provider. They have an opinion. They're like, if you get a token from us, don't put it in local storage, because it might be vulnerable to some to attack called cross-site scripting. Are they correct? Should you not put tokens in local storage? So let's talk about this. So in this talk, I'm going to run through common vulnerabilities that execute in your users' browsers. And then I'm also going to discuss modern application structures and how to take advantage of browser-based protections with those modern application structures. So basically, the first structure I discussed, your baby Mario, there's an attacker who is mushroom coming for you. You want to be Big Mario, so you get extra lives, right? So let's level up your tokens. So there are two common browser-based attacks. Typically, when you hear about hacking, you hear a lot about attacking other people's servers, getting into their databases, dumping the whole database. There's plain text passwords over there. Well, one of the more common types of attacks that can be a little bit less severe are browser-based attacks. So as an attacker, I am aiming to take over accounts from your users through their web browsers. Oops. So the first one I want to talk about is XSS. So I have stickers for prizes, if anybody can tell me what this is. I saw your hand first. What XSS is? You're correct. And do you know what cross-site scripting is? Anybody who can give me a definition can also get a sticker.
Using JavaScript to take over a system or make it behave in a way that you want it to. Basically, forcing JavaScript into the actual back end of the site. That's probably not correct.
That's pretty close. So what you're doing is you're injecting JavaScript into a website. There's 3 different ways to do that. The primary way is stored cross-site scripting. So you get it into the database, and then it comes back out as JavaScript into the website, and then users will load that. So Twitter had a pretty great cross-site scripting vulnerability years and years ago now. Somebody could put a tweet out with malicious JavaScript in it, and then when somebody else loaded their timeline and they were following that person, the JavaScript would execute. Or if you visited their profile, the JavaScript would execute in that other person's browser. So it's a little bit different to think about these attacks since they're browser-based instead of hitting a remote server. So both of you come see me afterwards, you'll get stickers. So when I test for cross-site scripting, this is what I'd start with. Usually I have a form box of some sort. I put script alert 1, script in it. And if I'm lucky and the client is unlucky, a pop-up box happens. Oh no, cross-site scripting. So what can you do with cross-site scripting? You can steal cookies. I can typically use JavaScript to take a cookie out of the cookie store and then send it over to my website. I can take actions as the user, for example, changing their passwords, transferring money, all sorts of nefarious actions depending on how and what your website does. I can even deface web pages. I can use JavaScript to completely change what the page says. So who knows what this is? Oh, microphone.
Can we use the microphone for the captioners?
Oh, yes.
Thank you. No, sorry. You have the answer, right?
Yeah.
Is a cross-site request forgery?
Yes. So CSRF, we usually call it CSurf, a little bit of surfing, is cross-site request forgery. And can anybody tell me what that is? So cross-site request forgery is when a malicious script loads on some website. So let's say, well, I have a diagram. Let's do that. So ultimately, the goal of this is to perform an action as the user. So you might visit a website that has a malicious script running while you're logged into your banking website. The malicious script will try to send a cross-origin request from the website you're visiting, like frowning.wtf, to your bank. And if you're logged in and the bank doesn't have CSurf protection enabled, the request will succeed. Money is transferred. You've stolen money really easily. So this is another thing that happens in the browser. The user has to be authenticated and logged into a session on another website, and this request can go across that There's a lot of common CSRF vulnerabilities with ads. So ad networks have to be super careful if they're going to do JavaScript-based advertising, because malicious people were like, yeah, I'll pay a penny to put a malicious ad on a good website, and then it will try to like hit all of the banks hoping you're logged in and that the banks don't have stuff configured properly. So can anybody tell me what these two have in common? I've definitely said it a little bit already, but you. Can you pass her the mic, please?
They all use JavaScript?
Well, funny thing about CSRF is it doesn't have to use JavaScript, but it's easier with it. But close. You should still come get a sticker. This is a hard question. So both of these attacks happen in the browser. And can anybody tell me how these two attacks are different? This is also a hard question, so. So cross-site scripting is typically worse than CSRF. And I have a graphic to demonstrate this. So in this case, cross-site scripting is the cow. Oops. So you saw the next slide, but how can we reduce the impact of these attacks? We can do that through architecture changes. So let's talk about a typical application structure. So I discussed this a little bit earlier, but typically you have frowning.wtf that contains your front end, JavaScript client like React or Vue.js client, and any monolith code. So your www website is probably serving JSON. It's probably serving HTML. It's probably serving JavaScript. It's probably serving all of your assets. And then you also have an API that's either serving XML or JSON, typically. And then you'll have an administrator site. You kind of have a little bit of a Frankenstein's monster going on www, serving all these different things, made of all these different parts. So where's your authentication stored? In your user's browser. It's probably in a cookie. That cookie is probably scoped to star.yourdomain.com. If it's not in a cookie, it's in local storage, and it's put there by your JavaScript. So one thing I've seen a lot of recently is people are using Redux to store their JWTs. Redux is like a JavaScript state machine. Your interactions to your API are typically going through XHR to /API. And for those of you who don't do front-end work, XHR is XML HTTP request, and it lets you transfer data between a web browser running JavaScript and a server without having to reload the page. It's super nice. So how would CSRF work in this case? Traditional CSRF protection assumes that you're using forms. Usually you take a token in an invisible form field that comes down from the server every time your user loads a page. And when they submit that form, that token gets submitted back up to the server, and the server checks it. It's like, oh, do these values match? Cool, generate a new one, submit the data, write it to the database. So your API might be using a CSRF token. It's not uncommon to see that, but it's not super common. Or your monolith might still be handling all of the CSRF protection, and your API has none of that. So depending on your application structure, your API might be vulnerable to CSRF. And depending on your website structure, you might be vulnerable to cross-site scripting. So before I dig too deeply into that, let's talk about one improvement you can make right away. Use subdomains. So instead of having frowning.wtf/API and /admin, put them on subdomains. Now you have api.frowning.wtf and admin.frowning.wtf. With this change, instead of having to scope your cookies to star, you can now scope them to www, admin, and API. and you can set particular browser-based flags on these cookies. And this tells the browser how they're allowed to send those cookies out. So you can set the secure flag, which means that the cookie will only be set over HTTPS. You can set the HTTP only flag, which means JavaScript can't touch it. These names are a little bit confusing. So HTTP only means only HTTP requests can access the cookie, no scripting. So you're still going to XHR your requests to API from your JavaScript frontend or www. So with that, how would you do CSRF protection for your API? It's going to depend on your content type. So I have another slightly difficult question for you guys. Can anybody tell me what the top 3 content types have in common? Go for it.
Are they just plain? I was going to say plain text, but I'm wrong.
Anybody else want to give it a shot? They're stickers. They look like this.
They're all unstructured.
Unstructured. Kind of. So they're all legacy form data types. When browsers introduced some cross-origin protections, they didn't want to break legacy websites. So multi-part form data, text plain, and application well, let's just say form URL encoded, can all go cross-origin. Application JSON can't, application XML can't. Basically, any other content type can't, except those 3. So how many of you have tried to deploy your website and you have multiple domains and you get a CORS error? It's like, oh, you don't have access control allow origin set as a header. Yeah. Well, to be able to share resources across websites, browsers developed browsers developed CORS. So can anybody tell me what CORS is? CORS is cross-origin resource sharing, not the beer. We care about CORS because of the protection offered by what's called the same origin policy. This says that scripts can't talk to other domains by default unless they have certain content types, because we didn't want to break legacy stuff. But we don't really talk about that legacy stuff. Most of the time, you see CORS errors when you're trying to talk to other domains. So the same origin policy, this is the description of it. Requests can't be made from URL 1 to URL 2 if they differ on any of these 3 following variables. If the protocol's different, so if you're trying to send a request from http.example.com to https.example.com, not going to work single origin policy violation. Same thing if you do port 80 versus port 443. If your subdomains are different, you're going to get a CORS error. And the other confusing thing about CORS is that it has to be set on the asset you're accessing. So if you're trying to send a request to Google Tag Manager from your personal website because you want to monitor who's visiting, place some ads, you can't do that unless Google has CORS set up on the endpoint you're trying to talk to. So if you're trying to send stuff from www.yourwebsite.com to api.yourwebsite.com, you have to configure CORS on API. And that's a little bit mind-bendy for some people because everybody's like, well, I just want to set it on my website and then be able to talk to whatever I want. But this is how the access restriction had to work. So given all of that, how do you reduce the impact of cross-site scripting? Well, in this new subdomain structure, your API doesn't have to run any JavaScript. So your data layer, not running JavaScript. www's still going to be running JavaScript and will be able to talk to API. So that part's not so great, but API itself, no longer an attack vector. And you can reduce cross-site scripting by making sure that you're not, you can reduce CSRF by making sure you're not accepting any of those 3 content types: multi-part form data, URL encoded data, and text plain. So if you don't want to deal with cores, you can use iframes. So browsers support window.postMessage, which is an API that lets you spawn an iframe and then talk to it directly. So it uses the DOM in your browser to enable cross-origin communication. Windows will be able to send and receive messages to each other through browser events. And this is kind of what it looks like. So I'd have www.frowning.wtf, and the user will input some data. Postmessage will send it over into API. API will be like, cool, I got my data. I'm going to take the authentication and now send it over to the server. The server's like, yeah, I have my authentication. I have good data. I'm going to send messages back to the API iframe. And API will pass that response back to www. And now you don't have to deal with cores. What you have to do instead is validate your origin. So the post-message API allows you to check where messages are coming from. It actually has event.origin as a variable, which is great. You can check that the message came from the right spot. So every time you take action on data that you're getting through post-message, you need to check your origin. The other thing you can do is use Websockets. Same thing, you have to verify your origin header. In order for me as an attacker to get around that, I would need to fake the origin header in the browser. Modern browsers don't let you set the origin header. You can set the origin header if you write like a bash script to go connect to this stuff, but the browser will not let you do that. So for WebSockets, a common problem is sites don't check their authentication before upgrading the connection. You need to make sure that your authentication is present, whether it's a JWT and a cookie, or you probably should just do a JWT and a cookie. The protocol upgrade request is going to have access to the browser's cookies, so check your auth. So some similarities between these solutions. Iframes and WebSockets are both going to have these trusty origins. How can you ultimately avoid CSRF on your API? You can drop all requests that aren't the content types you expect. So you no longer have to generate a random token, put it in your HTML form page, submit it back to the server and check it again. Now you can just literally write a middleware in your API and be like, you're not the right content type, bye. How can you avoid cross-site scripting? You probably can't completely. Modern frameworks like React and Vue now use a virtual DOM, which basically means they have like an interface between the DOM of your browser right here and then like data that's coming in, whether it's user data or data from your server. That virtual DOM prevents whole classes of vulnerabilities. So if you're using those frameworks, excellent. In React, you can say, hey, let untrustworthy input in without sanitization by using a method called dangerously set inner HTML. If you're using React, you should definitely add a check to your CI or your linter, and don't let that, that should never be merged. That's how you open yourself up to cross-site scripting. One common thing I'll see is people will use dangerously set inner HTML in libraries that they then import. And that's hard to catch. So it's really, really hard to avoid cross-site scripting completely. But CSRF, that's basically a solved problem. Just drop anything that's not the content type you're expecting. So earlier I mentioned Auth, and they were like, don't store your JWT in local storage. So should you store your auth in local storage? Can you prevent cross-site scripting completely? If you can, yes, go for it. If you can't, probably you want it in a cookie with HTTP only and secure set. So you'll have a good understanding of all of this if you can tell me why cross-site scripting is worse in all of these architectures. Security is kind of complicated and confusing. So if you can answer this question to yourself, you grasp this. And I would be remiss if I didn't mention Chrome announced on Friday that they're supporting a new cookie flag. It's called same site, and you can set 2 values for it, lax and I think strict. Lax will allow your cookies to be sent from a third-party domain. So let's say I have frowning.wtf, and I'm using Google Tag Manager again, so I want to talk to Google. Google has to set lax on those cookies. And now those cookies can be sent from frowning.wtf to Google. You can also then use strict, which will prevent which will prevent cookies from being sent cross-domain. That will be required for all cookies starting in March of 2020, I believe, with Google Chrome 80. So if any of you are developers, you're probably going to have to deal with that in the next 6 months. Firefox and some of the other browsers, Opera, Safari, et cetera, are taking their own pace on implementing features like this, but Chrome is for sure going live with that March 2020. So that means you don't really have to worry about a bunch of the CSRF stuff anymore if you set strict on your cookies. However, it's probably still a good idea to drop content types that you don't expect. So I just wanted to say thank you to a couple of people. LVH at Latacora was instrumental in me putting this talk together, as was Lee Honeywell at Tall Poppy, and the team at Latacora. The product security teams at Slack let me do a dry run of this on Friday last week on my first week, so that was very nerve-wracking. Good end of the first week, though. And does anybody have any questions?
I just want to remind everyone, if you have a question, please come to the microphone, and please remember to make your questions brief.
Hi. So the types of techniques that you're showing here are mostly targeted at devs. You know, these are people that are writing your APIs, writing your web interfaces and stuff to try to build a product that works together and is in a secure way. What are some techniques or tools you might suggest for those of us on the sysadmin side that might be building things like CI/CD pipelines for the developers to help catch stuff like this before it makes it into production?
Yeah. So for building into CI/CD, I highly recommend everybody pick up for their given framework or language some kind of secure coding. Oh, drat, the word just fell out of my head. Static analyzer. So, for example, if you're running Rails, there's a great one called Brakeman. You can set up all of the hooks that goes into your source code management, so it will run when developers create new pull requests. Some of those do require a bit of configuration, unfortunately. But if you Google your framework, static code analyzer, and then your framework, like top 10 vulnerabilities, you can disable most of the roles that look like they're going to be noisy and just keep the ones that are actually going to be vulnerabilities. If you can get a static analyzer with taint analysis in it, that looks where user input will flow through the application and will give you an idea of priority. Unfortunately, if you don't have a full-time security person, making decisions based on static analyzers isn't super easy some of the time because they're aimed at security professionals. So like, that's not like the best answer, but probably one of the better things you can do is getting a static analyzer.
Right, thank you.
All right, thank you so much for your talk.